I don't know if a lot of my viewers have any interest in rocks and minerals, but because I have interest in it, and these videos overview star evolution, basically talking about rocks and minerals is essential to understanding what a star is comprised of. Now, I've always been fascinated with gems like amethyst and emeralds and diamonds. So I'm going to go ahead and talk about amethyst here because I think the purple gems are exquisite. I love the way they look. It says here, amethyst is a purple variety of quartz, which is silicon dioxide, meaning two oxygens and one silicon atom, and owes its violet color to irradiation, iron impurities, in some cases in conjunction with transition element impurities, and the presence of trace elements which result in complex crystal lattice substitutions. The hardness of the mineral is the same as quartz, thus it is suitable for use in jewelry. Here are 5 grades of amethyst. I'm not too sure if people are aware of, but there's grade B, grade A, grade AA, grade AAA, and grade gem. As you can see, the further you go, the deeper, more purple, more clear the gem becomes. And that's because of the crystal lattice lining up. Here we have crystalline SiO2, which is quartz. Could be amethyst if it had the iron impurities and things. The Si is the purple, the silicon, or no, the red, and the oxygen is the blue. This is amorphous, meaning there's not any crystalline structure to it. If you were to break it, it would shatter. Obviously this would shatter too, but it would shatter along cleavage lines, I believe. I have to look more into that. But it can be SiO2 glass. This is similar to a lot of the beach sand that I encounter on the beach, which is similar but not exactly. And this is the crystals that form naturally and grow. Here's one example of a very large geode, which has amethyst crystals inside of it. I think this is really, really cool how these blobs of material cool, and on the inside these crystals just grow right on the substrate of the agate. Very, very beautiful stuff here. And of course the basic diagram again. All stars form rocks and minerals being silicon dioxide in crystal form. In other words, gemstones are the result of stellar evolution. As a star cools and dies, the gases combine into liquids and solids and cool. The rock cycle doesn't have any method for forming gemstones, such as amethyst, because you can't really recycle amethyst. It just grows and it just stays put. It doesn't, I mean, you can make it into sedimentary rock and metamorphic rock, but after it forms, it stays put in its crystalline form. If you were to destroy it with the rock cycle, it wouldn't be a crystal anymore. It would be glass, or it would be sand. Alright. Just so people know, the formation of gemstones and gemstone quality material, and even granite and feldspar and every single rock and mineral on the earth, is a direct result of a star cooling and dying. So basically when you pick that stuff up or you wear it on you, you're wearing the components of a star. Alright.